So we were looking at percents yesterday. We were looking at converting between decimals, fractions, and percents. So today we're going to start off with the calculations. And we looked at things like converting that fraction of 3/5 into a percent. We could think of that as being 3 out of 5, and a percent is always out of 100. So to find what percent that is, we cross multiply. 3 times 100 is 300. And divide by the 5, giving us 60. Well, 60 over 100 is 60%. Today, as we start doing our calculations with percents, we're going to use that same setup. It's called the proportion method. So for the proportion method of percents, we might have a simple problem like blank is 45% of 68. So when we're dealing with percents, we always start with the percent. So you got 45% is 45 out of 100. Before we go any further, let's define what that really means, 45% or 45 out of 100. The 100, we had mentioned yesterday, 100% is 100 over 100. That means the whole thing. So the 100% is the whole thing, or the starting value. It is the basis of our calculation, called the base. All of our calculations are based off of that. For example, if you go to the store and you buy an item that is $6, you're going to pay $6.33 because of sales tax. The amount of sales tax is calculated based on the $6. So that $6 is your base. That would be representing the 100%. That's what you're starting with. The 45 or whatever other percent we have up there then is a portion of interest. That is a part of that base that we're focusing in on. So out of that whole thing, this is the piece that we want to look at more closely. So then as we look at this problem, we got to set up the other half of the proportion, and we have to match things up. Remember, we have to have those relationships. Well, blank is 45%. That implies that the blank, or the missing number, goes with the 45. Also, we have of 68. You can read that as out of 68. Implies the 68 goes on bottom. We cross multiply and divide. 45 times 68 divided by 100 gives us 30.6. So 30.6 is 45% of 68. Now these problems can look a lot different. We might have something like this. Now let's do another simple example first. Blank is 140% of 90. So where do we start here? %. That would be 140 over 100. On the other side, we have a missing number and we have the 90. Remember, blank is 140. And you also think of this as out of 90. Well, the out of 90 implies the 90 has to go on bottom. Blank is 140 implies that missing number matches up with the 140. And we can cross multiply and divide. 140 times 90 divided by 100 is 126. Now here we got 126. We said that's a portion or a piece out of our whole amount. 90 is the whole amount. Why is the 126 bigger than that? Because our percent is bigger than 100. If we have more than 100%, we're going to have more than the whole amount. So this one here looks quite a bit different. 70% of 20 is blank. Well, we still have the percent, 70%, 70 over 100. This is what confuses people now, is because the order of the numbers here. Where does the 20 go, top or bottom? Bottom. Think of that as out of 20. So it goes on bottom. Some textbooks actually teach something is over of. I don't know if you ever heard of that one. Is blank means the blank goes on top of 20, means the 20 goes on bottom. For these simple little sentence problems like this, that works out. But when we get into some of our story problems, that doesn't work. So I hesitate to teach that, but it is something you can always fall back on if you're really stumped. So now 70 times 20 divided by 100 is 14. 14 is 70% of 20. $42 is 60% of blank. So we've got that 60% again, 60 over 100. Where's the 42 go? Careful. 42 is 60. Goes on top. Of 100 or of blank, think of out of blank, means that blank goes on bottom. You'll notice the numbers are in a different spot now. The missing number's down here instead of on top. It is still cross multiply and divide. 100 times 42 divided by 60, which is going to be 70. So 42 is 60% of 70. Here we have 30% of blank is 42. So we got the 30% is 30 out of 100. Where's the 42 go? Top. Of blank implies out of blank. It implies the bottom, the missing number goes on bottom there. So again, it's cross multiply and divide. 100 times 42 divided by 30 is 140. 30% of 140 is 42. We can even have numbers that look like this. $24 is blank percent of 40. Well, I said we always start with the percent, but here we're missing the percent. Well, it doesn't matter. We're still going to start with it. Blank percent means blank over 100. On the other side, we have the 24 and the 40. Which one goes on top? 40 goes on bottom, yes. Often that's easier to think of it as out of 40. 24 is blank, so the 24 goes with our missing percent. Now notice once again, the missing number's in a different spot, but it doesn't change our calculation. It's cross multiply. 100 times 24 divided by 40 gives us 60. 60 out of 100 is 60%. So 24 is 60% of 40. So blank percent of 90 is 18. Well, again, we're missing the percent, so it's blank out of 100. Which number goes on bottom? 90. Of 90, think of this, out of 90 implies bottom. Blank percent is 18, implies the 18 goes with the missing percent. Cross multiply and divide. 100 times 18 divided by 90 is 20. 20% of 90 is 18. Any questions so far? Okay. Like I said, this is the proportion method. I really like the proportion method because all you've got to do is match up the numbers, get them in the right spot, and it's always cross multiply and divide. Calculation is always the same. There is something called the rate method of percents. And the rate method for calculating percent involves turning the percent into a rate. Now a rate, remember, is just the decimal. So 45% as a decimal would be 0.45. Remember, it's dividing by 100, which means we just have to move that decimal point 2 spots. So for this problem here, that would have been calculated by taking our 68 times that rate of 0.45, which would be 30.6. That's the answer. Now that seems pretty simple. Let's look down here. 140% is what as a rate? As a decimal. Move the decimal 2 spots is 1.4. Very good. So then we take our 90, multiply by 1.4 is 126. Same answer we got before. Better be the same answer, right? And then finally this one, 70% becomes 0.70 or just 0.7 if we want to leave it that way. And we're going to take 20 times 0.7, which would be 14. So we get the same answer, and this rate method seems to be less work. And in some cases it is. You know, for this one here, when we have the whole amount, it's pretty easy to find out what that portion is, that piece of interest. Where the rate method becomes a little more confusing is when we get into different types of problems. This one here, we have 60%. What does that become as a rate? 0.6. Now in this case, it would not be 42 times 0.6, it would be 42 divided by 0.6, because what we have is the portion of interest, and we're looking for the whole amount, the base amount. That would be the 70. Same with this next one. 30% becomes 0.3. That one would be 42 divided by 0.3, which is 140. So you can see if we're going to use that rate method, you convert it to a decimal, but then you also have to figure out whether you're going to multiply by the rate or divide by the rate. And there's even a third possibility. When you're missing the percent here, you have to take the portion, the 24, divided by that whole amount or that base amount of 40 to get 0.6. Then you convert that rate into a percent. So the rate method is quicker if you can look at it and figure out what piece goes where. Are we multiplying by the rate? Are we dividing by the rate? Or are we dividing this out and converting a rate into a percent? The rate method is most useful. There's no charge for the extra E. Most useful when we have that whole or base amount and we're trying to find that portion. that piece of interest. And there are applications where we use that rate method for that because of that. For many of our word problems and stuff, though, I prefer to use the proportion method because it actually helps us line stuff up. Let me show you what I mean. MLB Corporation estimates monthly profit as 8% of gross sales. What is gross sales for a month when profit is estimated at $33,840. So here we have a percent, 8%, 8 over 100. Before we do anything with that, let's label, what does the 8 stand for? Well, 0.08 if you wanted to make it a rate. But in the problem, what does it stand for? We have profit and we have gross sales. The 8% is used to find what? Which one's bigger, gross sales or profit? Careful. Yeah, you have your whole sales and only a portion of that's profit, right? The rest of it goes to cover expenses. Right? So your profit's a piece of that. The profit is calculated from the gross sales. Estimates monthly profit as 8% of gross sales. So gross sales is your base. That's what's used to calculate the profit. So the 8% is the profit. Now, when we look at the other side of that, we have the 33,840. Does that represent the gross sales or does that represent the profit? Profit. The profit is estimated at 33,840. So that helps us to set this up so we can cross multiply and divide. 100 times 33,840 divide by 8 is $423,000. So you have gross sales of $423,000. What do you think? Not so bad? Sales tax is 6%. What is the list price for an item when sales tax is $20.40? So we've got that 6%. The 6% obviously represents sales tax. The 100%, the basis is not the total, it is the list price, right? It's the price of the item before tax. because you use the price of the item to figure out what the tax is. So on the other side, we've got the 2040. Where does that go? It is the tax, sales tax up, 2040. It has to go with the tax. So we cross multiply and divide. 100 times 2040 divided by 6. $340. Does that look right? Perfect. So that was the list price. Now, what if they were to ask, how much did you pay? How would we find that? Perfect. You bet. We add that tax to the list price, $360.40. Any questions? Let's see. Sam receives a 12% discount. How much does Sam pay for items listed at $450? So we've got 12%. What does the 12 represent? Discount. What's the 100 represent? The listed price, the list price. So over here, what does the 450 represent? Listed price, that goes on bottom. We cross multiply and divide. 12 times 450 divided by 100 is $54. What does that represent? The discount. Is that what we're looking for? Yeah. How much does Sam pay? So to find that, we can find that from these numbers. Take the list price and subtract the $54. $396 is the amount she pays. Tony marks items up 30%. How much does Tony charge for an item that costs $70? So again, we've got that 30%. The 30 represents the markup. Now, being a merchandising example, you may not be familiar with the concepts enough to pick this out. The 100, the basis is the cost. That's what Tony pays for the item. In the problem, we have the $70 that represents the cost. So that's going to go on bottom. We will cross multiply and divide. 30 times 70 divided by 100 is 21. What's the 21 represent? Markup. Is that what we're looking for? No. Once again, this time it's not subtracting it from the 70, it's adding it to the 70. $91 is what Tony is going to charge. Now, these last two problems are examples of percent increase and percent decrease problems. If I go up here, this was a percent decrease problem. We had a full price here, or list price. We subtracted a discount to get the amount paid. Well, if I look at that, the list price was 100%, right? It matched up with 100. The discount was 12%. If I subtract that, 100 minus 12 would be 88%. That 88% would have worked to calculate this. Instead of finding 12% and subtracting, I could have just found 88% of 450. Once I cross multiply and divide, I would have got $386. Or down here, this being an increase, the 70 was the list price. Or sorry, not in this case, not the list price. The 70 was the cost, what Tony paid. The 21 is the markup. The 91 is what Tony sold it for. So again, we can look at the cost being 100%. That was the basis of the calculation. The markup is 30%. That resulted selling price is 100 plus 30 or 130%. Rather than finding 30% and adding it on, we could have found 130% of that $70 cost. And if we cross multiplied and divided, that would give us $91. Now, in these two examples that we did here, it doesn't make a whole lot of difference either way. But there are examples where we have to think of that, that 130% or the one up above the 88%. Let's talk about that discount, or what's called a percent decrease problem. In a percent decrease problem, there's always a hidden percent. It's called a complement. If you are getting a 30% discount, what percent do you pay? You pay 70%. Where did that 70% come from? Well, the whole amount is 100%. You subtract the 30% discount. That means there's 70% left over. You pay 70%. Those percents are called complements because they add up to 100. Anytime there's a discount like that, the discount and the percent paid have to add up to 100. How much does Frank pay for items listed at $600 if there is a 2% early payment discount? We could find 2% of the 600 and subtract it out. But if there's a 2% discount, what percent does Frank pay? What's 100 minus 2? 98. So Frank is going to pay 98% of that list price. So the 600 is the list price. Find what Frank pays. 98 times 600 divided by 100 is $588. $588 was paid. Now again, we could have found the 2%. 2% of 600 would give us $12. Had we subtracted the $12 from the 600, we would get the 588. So why on earth do we want to worry about this whole idea of complements? Well, because sometimes you have to. Let's say that after a 6% discount, Pat pays $329. How much did Pat save? If we look at that 6%, of course, the 6% represents the discount. 100% represents the full price or the list price. Are we looking for one of those items? How much did Pat save? Well, that would be the discount, wouldn't it? So we are looking for the discount. So that looks promising so far. In order to find that, then we would need to know the list price. Do we know the list price? No. The list price is before the discount. We know Pat paid $329. That's after the discount. So we don't know this number here. So this isn't going to work. But if we do the complement, if the discount is 6%, 100 minus 6 is 94%. 94 means the price after discount. 100 is still that full list price. The 329 is the price after discount, so that can go on top. Cross multiply and divide. 100 times 329 divided by 94. We get $350. Is that our answer? That's the full price. We're asked, how much did Pat save? So we do still have to go back and subtract. $350 is the full price. Pat paid $329. The difference is $21. Pat saved $21. So using the complement doesn't guarantee that we don't have to go back and add or subtract. It just means we are able to match it up with that price after the percent has been applied. Any questions there? On the other side of it, similar to that, after 12% tax, you might think 12% sounds a lot. You check into a hotel room Depending on the state and the city you're in, it's anywhere from 12 to 18% tax. So they might quote you a price of $90, you end up paying like 112 bucks. There's some pretty hefty taxes. So let's say after 12% tax, Alex pays $504. How much was the tax? So again, we have that 12%, 12 over 100. And 12 does represent the tax. The 100 represents the before tax, right? What are we looking for in this problem? How much was the tax? That's this number. That works. Do we have the amount before tax? No, the 504 is after tax. So again, we have to adjust our percent. Now this time it's not going to be 100 minus 12 because tax does not get taken away from the price, it gets added on. So 100 plus 12 is 112%. So 112 out of 100. The 112 is the after tax, and the 100 is still before tax. The other side of that, the 504 is after tax. Cross multiply and divide. We have $450 here. So before tax, that was $450. Is that what we're asked to find? We're asked to find how much was the tax. So the total with tax is 504. The total before tax is 450. That's $54 in tax. What do you think? Not too bad. Taxes, allowances like waste allowances and stuff like that are things that sometimes are done with rates. Like if you know the list price, let's say there's 6% tax, you know the list price, to find the amount that you're going to pay, you can just use a rate. Or to find the amount of tax, you can just use a rate. So let's say you have the list price and you want to find the amount of tax. Well, if I have just a $28 item for list price, to find the amount of tax, I'm going to multiply by that rate. 6% is 0.06, giving us $1.68 in tax. Other examples where we would use the rate might be a waste allowance. Let's say you allow 10% for waste on materials. Really doesn't matter what type of materials they are. It could be cloth for making something, could be wood for building something. Let's say you calculate $950 for materials. How much should be allowed for waste? Well, it's $950. times your 10% waste allowance. That's $95 that should be allowed for waste. Make sense? Now you can combine this with what we learned up above with our percent increases. If we want to know what should be your total budget item, well, your 950 instead of times 0.1 for 10%, remember 100% plus 10% is 110%. So that would be 1.1 is the rate for 110%. That is up to $1,045. That should be your total budget for that project. Now, again, that could have been found simply by taking the 950 plus the 95 allowance as well. So on many of these percent problems, there's more than one way you can go about getting to the answer. Just make sure that whatever you are calculating from, whatever you are matching up with the 100% in that proportion, is really the base amount, the amount that the calculation should be based off of. Because when we make this proportion, let's say we've got 45%. Whatever number goes here, matching up with the 100, is the base amount. That is the number in the problem that all the other calculations are based off of. If you go on to take business math with business applications, we'll talk about markup. Markups based on cost, which is kind of the example we did a little while ago. There's also markups based on selling price, where the selling price is used as the basis of the calculation. So you have to make sure you keep those things clear. Remember, there is a quiz due tonight at 11:59 p.m. There's a homework due Monday in class time. And then just a warning coming up. Test 3 is next week, Thursday. So next week, Monday, we'll have lecture on new material. We're going to talk more about percents and uses of percents for like commissions and interest and stuff like that. Next week, Wednesday, we'll have a little bit of a review. And Thursday is Unit 3 test. And that'll leave us with 5 weeks to do Unit 4. Any questions? Okay, well, you guys have a great day.